Hi everyone. In this video, we are going to learn how to multiply polynomials. We have 4 learning objectives. First, we look at how to multiply monomials, and then how to raise a monomial to a whole number power. And then we look at how to multiply a monomial by a polynomial, basically its distribution. And then the last one is our ultimate goal for today. We want to multiply polynomials. So let's look at them one by one. First, we want to understand this formula. So basically, you have 2 exponential operations here, a to the power of m times a to the power of n equals the same base a. Then all you need to do is add these 2 exponents. Now, I'm going to use this example to demonstrate, to prove that this formula is true and actually makes sense. Okay, I'm not going to use this formula because I want to illustrate how we get this formula. So x squared, by definition, is this base x multiply itself twice, right? This multiplication, we need to do exponential operation first. So we get x times x, that's x squared. X cubed means x times x times x. This is by definition, right? What's in between? In between, we have multiplication here. So they all multiply together. There's no difference which x belong to which expression originally, right? So how many x altogether? It's 5. We're supposed to get x to the 5th. How we get 5? First, we have 2, then we add another 3. They all add together totally. So x 2 plus 3. And that's this formula. You just add these 2 exponents. When you multiply exponential forms with the same base, add exponents. So that's our first formula. Now you get this exercise problems, 3 of those. And answers to the exercise questions are in the comment area. You may ask the questions if you have any. And also, let's look at this second topic, how to multiply monomials after we learn that formula. Now, let's look at example 2. In this example, we have 3 monomials, negative 3x to the 5th, 4x squared, and 5x. Now, we all know that in multiplication, order doesn't make any difference, right? 2 times 3 equals 3 times 2. So for that reason, we can put all the numbers together because they all multiply together, no matter numbers of variables. So negative 3 times 4 times 5, then times x to the 5th, times x squared times x, because order doesn't make a difference. So now I can multiply numbers together. This is 20 times 3, 60, so negative 60. When we multiply exponential forms with the same base, we just learned that formula on the last page. We add exponents, 5 plus 2 plus 1, that's 8. That's the final answer. So it's not that hard to do, right? Now, this is a summary of how to multiply monomials. Multiply the coefficients, that means multiply those numbers. Negative 3 times 4 times 5 to get negative 60. Then add the exponents of like variables. That means same variables. Since we have same variable, you just add all of the exponents together. In other words, you don't need to go through this step after you understand that. All you need is to multiply number together and get this final number, add exponents for the same variable, and you get this final answer. So you don't have to go through this middle step. That's after some exercise. Now, your second set of exercise questions. Our next topic is to simplify monomials raised to a power. In other words, how we simplify if a monomial raised to a power. So basically, you're going to use our next figure. Let's look at the formula directly. It's much easier to look at the formula than read this. This is just description of the formula, by the way. Now, let's look at this formula. Notice the structure of this formula. Inside the parentheses, you have a form of exponential operation, a to the mth power, right? But this power itself serves as the base to another power. So this whole thing is called power to a power, okay, power to a power. So if you have a power to a power operation, you still have the original base in your answer. All you need to do is multiply these two exponents. Instead of adding, you multiply them if you have two exponents in a row. Now, let's prove or illustrate this formula using this particular example so that this formula actually makes sense to you. Everything has to make sense to be correct. Okay. Now, we do this by definition since we cannot use this formula if we want to prove it, right? So fourth power means you multiply base by itself 4 times, and our base is x cubed. That's our base. So I'm going to multiply x cubed by itself 4 times. Remember the very first formula we learned? When you multiply with same base, you add exponents, right? So I get same base, 3 plus 3 plus 3 plus 3. So what is 3 plus 3 plus 3? By definition, this means multiplication, because multiplication is nothing more than same number addition. That's the nature of multiplication operation. We have 4 threes. So all we need is indicate we have 4 threes. See, m times n, you multiply these exponents together in the end. That means you have x to the 12th. But final answer is not our goal. Our goal is to demonstrate this formula. When you have power to a power, you multiply exponents. The base remains the same. Now, another formula before we use them to simplify a monomial raised to a power. Look at this formula structure. You have AB as a base. AB means A times B. In algebra, if there's no operator in between, it means multiply. Also, in addition to this being multiplied, even though we only have 2 factors, A and B, whenever numbers multiply together, we call each of those numbers a factor, okay? Even though we only have 2 factors, it could be many. It just illustrate something that multiply together. As long as you have these factors multiply together as a base and then raised to a power, then each of these factor will raise to the same power. It's like you distribute this exponent to each factor inside. Okay, now I'm going to use this formula, this example to demonstrate this formula again, so that you know this formula actually is correct. Okay, fourth power of this base, we are going to multiply this base by itself 4 times. Sometimes we just have to go through the tedious work to make sense, to learn something. Right? Multiply by itself 4 times. And again, we have a quantitative property of multiplication, order doesn't matter. For that reason, I'm going to multiply all of the numbers together, because again, order doesn't make a difference. Then I multiply all of the variables together. They all multiply together, by the way. They all multiply together. X cubed times x cubed times x cubed times x cubed. So now this is by definition 2 raised to the 4th power. And this by definition, we multiply x to the 3rd by itself 4 times. Is equivalent to this. And what is this? You distribute this 4 to each factor inside, because your factor is 2 times x cubed inside. Then you apply this exponent to this factor, you get 2 to the fourth power. You apply this exponent to this factor, you get this portion. So we just demonstrate this formula that is correct, actually. Again, if we continue to simplify it, we get a final answer, but this is the end of it if we just want to demonstrate this formula. But let me finish it anyway, right? 2 to the first power is 16. So x to the 12th power. Okay, next one. We are ready to simplify a monomial, which is the base in this case, raised to a power. So we notice that this is the formula we just look at, right? This is called a product to power because A times B means product. Product to a power. You can distribute this exponent to each factor inside the base. So let's go ahead. -4 is one of the factor, and x squared is another factor. So we just do distribution. Then we multiply -4 by itself 3 times. We know negative number multiply itself odd number of times. The result is negative. So -64. If you use a calculator, suppose if this is what if this is decimal? If you use a calculator, you don't need to input the sign. You just use a 4 in this case because you already know the answer is negative. Why bother to carry negative sign? The more buttons you push, the more chance you make mistake. So multiply these two together, x to the 6th power. I guess you're going to have another exercise set on the next page. Yeah, here it is. This is your exercise questions. Now we are getting closer and closer to our ultimate goal, which is multiply a polynomial by another polynomial. This is just another step we need to go through. So how to multiply a monomial by a polynomial or polynomial by a monomial, they're the same thing. So basically what this how means you just do distribution. You distribute that monomial to each term inside that polynomial. So let's look at these examples. We have at least 2 examples. So we have monomial, we have polynomial. You distribute the single one to each one inside. Actually, it makes sense because all of this together to represent this whole thing. In order to multiply this whole thing, you have to multiply each one of them. But I'm going to use an analogy here to see actually this makes sense before we actually multiply them together. Okay. The 2 times 3 plus 5. If we use order of operations, we would have to add these two together. 2 times 8 equals 16. So we know 16 is the correct answer. But suppose we don't do it this way. Instead, we do distribution. This is like monomial and polynomial. Multiply each one inside by 2. So we get 2 times 3 plus 2 times 5. And what do we get? 2 in front of 3, 2 in front of 5. We don't change this plus. So basically, we just insert 2 in front of each one by this distribution. What do we get? 6 plus 10. Do we get 16? Absolutely. Actually, this total makes sense because it's 8 times 2 really means 8 2s. Look at what we have after we do distribution. We have 3 2s plus 5 2s. How many 2s? 8 2s. Even though they look differently, they mean exact same thing. Sure, we have same answer. Hopefully this makes sense to you. Now we are going to do distribution. I'm going to do this one literally, and the next one we can go a little bit faster. So this is 2x times 3x squared plus, this is a positive term times positive, still positive. So that's why I have plus here, 2x times 4x, and positive times positive, still positive. So 2x times 1. Now simplify it. Number times number, 6, x times x squared, that's x cubed because we add exponents. And then 2 times 4 is 8. x times x is x squared, then plus 2x. So that's the final answer. Actually, we can save this step because once you understand, you need to do distribution, do this in your head because the number is really small. 2 times 3 is 6, x times x squared, x cubed. 2 times 4 is 8, x times x, x squared, and so on. So we don't need to go through this first step, actually. So now let's look at the next one. I'm going to do it a little bit quickly this time. -3 times 4, -12. Just add exponents because they are the same variable. 2 plus 2 is 4. Next one, negative times positive is negative. That's 15. This is 2, this is 1. Totally is 3 because when you multiply, you add exponents. Now -3 times -6, that's positive 18. We don't have any change in x, we just copy this. So x squared. So that's the final answer. Now your turn to do the exercise, monomial times polynomial. Now, finally, let's look at how to multiply two polynomials. Basically, the way you multiply two polynomials is also distribution. It's just more distribution. Now, let's look at the example to see how this works. Say I have this first one, x plus 5. Even though we only have two terms, generally speaking, it is a polynomial. So polynomial times polynomial. The way you look at this is that you treat this first polynomial like accumulation of monomials. In other words, the way I see it, it's just two monomials. This is a monomial, this is a monomial. In other words, first I do this monomial x times this polynomial. Then I do another monomial, positive 5 times polynomial. In other words, it doesn't matter how many terms I have. I just treat them like monomial times polynomial. Just repeat this process. Okay, let's do that. X times x, then x times 1. X times x, x squared. X times 1, still positive x. So this way I finished distributing the first monomial, which is x. Then I move on to the second, which is positive 5. Positive 5 times x, positive 5x. And positive 5 times 1. And positive 5 times 1 is positive 5. Now, combine like terms, don't forget this step, x squared plus 6x plus 5. Now, I guess I have to say something about this kind of polynomials, even though that's a different topic, but this is a good opportunity for me to see that. Now, notice this structure. You have x term, you have a number. You have x, you have number. When they multiply together, you always get these three terms, x squared term, x term, and the number. Because when x times x, you get x squared. When x term, no matter the number in front of it, okay? And x term times number, you get x term. Number times number, you get another number. You always have these three terms. It's just a matter of what numbers in each term. So understanding that, we can do this faster. Now, how we do that faster? It goes like this. If you only have x without number in front of them, which means 1, all you need is this. First one is always x squared, because x times x is always x squared. The last one is always 5, always a number, because number times number can only get a number. Only difference is the middle term. How do we get 6? Add these two numbers together. In other words, add the two constant numbers together to get the middle term, multiply them together to get a constant term, and that's it. You don't need this step. So let's try it the same way here. You got x squared, add these two together, positive 4, negative 3, that's positive 1 for x. Multiply them together to get a constant term. Sorry about that, you don't see that. Let's repeat it. So this one has exactly the same structure. X times x is x squared. For the middle term, all I need to do is add these two constant numbers together, positive 4, negative 3, that's positive 1. Multiply them together to get a constant term, you get negative 12. So you don't need to do distribution. But if you want, sure, why not, right? If you feel more comfortable doing distribution, ultimately you have same answer. There's no difference. Now, how about this tool? And I'm going to do this also. First, we do distribution. At least everybody can do it after this demonstration. Then I do it one more time on the right side to make it a little bit faster. Okay. So first, we do distribution. Distribute 3t to each term in the second polynomial. So we get 3t times 4t, that's 12t squared. Then 3t times 1, that is a 3t. So finish distributing 3t. Now negative 5. Remember, don't forget negative sign. After you distribute 3t, 3t is gone. It becomes part of this. This whole thing is gone. You just have negative 5 left. So negative 5 times 4t, that's negative 20t. Negative 5 times 1, that's negative 5. Combine like terms. 12t squared, 3 minus 20, negative 17, and minus 5. And that's the final answer. Now, let's do it a little bit differently. Just give you a choice. You don't have to do it this way. Again, we know the final answer has similar structure. You're going to have t squared term, you're going to have t term, you're going to have constant term. So t squared term has to come from this t times t. There's no other possibility. So we get this 12t squared already. And the number term can only come from number times number. There's no other possibility. So negative 5 times 1, that's negative 5. It's just a matter of the middle term, t term. How do we get t term? There are two different ways. These two inner ones give you t, because number times t give you t. These two outer ones, also outside ones, also give you t terms. So put them together. This is negative 20, and this is positive 3. Negative 20, negative times 5. 3 times 1 is 3. Combine them together, negative 17 for t. So you can do it that way. It's totally up to you, just different ways to look at things. Otherwise, there's no fundamental difference. So I'm going to do this a little bit faster. 2x, 3x, 6x, and this give you negative 15. This 2 give you negative 2. So totally I have negative 17 again. And negative 5 times negative 1, positive 5. So that's the final answer. Okay. Another set of exercise questions. Now, finally, we want to look at some special binomials. We call them conjugates. What are the conjugates? Basically, two binomials with opposite signs before the second term. Some examples: x plus 9, x minus 9. The only difference is the sign before the second term. How about these two? Similar structure. Whatever they are, doesn't matter. The difference is that they only differ by sign in front of the second term. That's called a conjugates. Why this is important? Because when you have conjugates, it's not one term. Okay, both conjugates, once they multiply together, you get a very special structure in the product. So let's look at it. Now, here is the general format of conjugate. A can represent anything, B can represent anything. So only difference between these two is the sign in front of second term. So what's the result? The result is first term squared minus second term squared. It doesn't matter what AB is. AB actually, each one could be an expression in itself. In other words, this is about a structure. It's not literally two variables, okay? It's about a structure. Now I'm going to demonstrate this by doing the distribution to see what really is going on in between so that you know this one actually makes sense. Okay, distribute let's distribute A first. A times A is A squared. A times negative B is negative AB. Now B times A is positive AB. B times negative B is negative B squared. These two are exactly opposite cancelled. You get A squared minus B squared. So we know this is true, no matter what A and B represent. Now let's apply this formula, apply this structure. So we notice that these two are conjugates, only differ by the sign in front of second term. So this is our A, this is our B. So A squared minus B squared. That's all it is. 4x squared, make sure the whole thing is squared, not just x, okay? Minus 49. So instead of doing distribution, apply this formula, it's way faster. Actually, don't need this step even. You just square this, put it in here, square this, put it in here, there's minus sign in between. Now, another set of exercise, move on to example 7. This time we multiply a binomial and with a trinomial. Generally speaking, it still belongs to the category of multiply polynomials. We do distribution. There's no special formula when you have multiple terms. So we just distribute each one to the second one. So let's do that. Since this is single x, right? X doesn't have a number in front of it, means 1. That means you only change the x term by raising each one higher by 1 in terms of exponent. So you get 2x instead of 2, you have 3. It's plus 5 instead of x, you have x squared minus 3x. Just put an x on top of each one of this. Now positive 4 multiply everything in the second polynomial. And plus 8. By the way, if you want to have a little bit easier time when you combine like terms, when you distribute second one, put it underneath the first result. 4 times 2, that's 8x squared. This is square term. 8x squared. 4 times 5, 20x, positive 20x. 4 times negative 3, negative 12. Now combine like terms, 2x cubed. These two combined, positive 13x squared. These two combined, positive 17x minus 12. So that's our final answer. Just practice, really nothing more than that. Practice. After you understand basic structure. Okay. Exercise number 7 and example 8. Write an expression for the area of rectangle shown below. We know the area formula for a rectangle is length times width. So instead of given two numbers, specific numbers, we have two expressions to represent the length and width. No difference. So we just multiply length by width to get area. That's the formula for the area of rectangle. Length is 3x plus 1, and width is 2x minus 3. So we can do this multiplication fairly quick because we already know the structure of the result. You have x squared term, you have x term, and you have numbers. X term has to be x times x. I mean, x squared term has to be x times x. That's a 6x squared. Number times number give you another number. The middle term comes from these two triangles. This is a positive 2, and this is negative 9. So totally negative 7 for x terms. Yeah, that's a final answer. Sure, you can do distribution. It's totally up to you. Totally up to you. Now, the final example we have for this video is write an expression for the volume of the box shown below on the next page. So we have this. And really, there's no fundamental difference than the previous one, except we have 3 expressions to multiply together instead of 2. So volume of a box equals length times width times height. Length, width, height. So equals 5x plus 2, 5y, I mean. 5y plus 2, y minus 4, and times y. Okay, let's do it a little bit faster. Y times y terms, that's y squared term. And these two triangles give you middle term. This is the positive 2, and the other one is negative 20. So negative 18 in total for y. And number times number give you another number, that's minus 8, and multiply by y. So everything has one more y, just increase y exponent by 1. Y cubed minus 18y squared minus 8y. So that's a final answer. Yeah. And also your last exercise question. That's all for this one. See you in the next video.